Do you want to get started with AIP? The Speedrun, your first AIP workflow course on learn.palantir.com is a great place to start. And today, we'll be walking you through how to do it. In this tutorial, you'll create an AIP workflow by transforming PDFs into a knowledge graph and using an AI agent for accurate answers. You'll extract key information, map relationships, and visualize the graph. Finally, you'll build an interactive app to query the graph. This will prepare you for more advanced projects using Foundry and AIP. Let's get started. Starting from learn.palantir.com, you'll be able to find the Speedrun, your first AIP workflow course, either on the homepage or by navigating to the course catalog and clicking on the course. Ensure that you're signed in to learn.palantir.com and that you're registered for the course. In the course introduction, you'll be able to find a high-level overview of the course, instructions for getting help and finding the documentation, a summary of the permissions that you'll need to complete this course, and an overview of the use case. In this use case, say you've joined a team focused on tuberculosis at a charity working to expand medication access. To efficiently navigate the large research library, you use AIP to build a Foundry workflow. Before getting started, we draw up an architecture graph. At the very bottom, we start with data. The data in our case is a media set of articles. After which, we perform document processing using Pipeline Builder, divide the data asset into chunks and entities, surface the chunks and entities to the ontology, use AIP logic for ontology data generation, and Vertex to create a knowledge graph, culminating in a literature review app that's built in Workshop. Before we start building, let's go through the app that we're going to build together. As a user of this application, I want to ask questions about tuberculosis and get real evidence-backed answers. In this application, when I type in a question, there'll be a semantic search performed, which will show us the 10 most relevant chunks from the set of articles that we have. On the side here, we have a Vertex graph, which shows us the relationships between chunks derived from the research articles and their related entities. So when I type in a question, such as, why is multi-drug-resistant tuberculosis a concern? The list of chunks from the literature here will get narrowed down to the top 10 most relevant results based on the semantic search. And notice that the corresponding graph in Vertex has also become limited to the 10 most relevant chunks to my question. And down at the bottom, I have a generated text response to my question, which provides an answer with numerical evidence. By using a large language model in combination with the ontology, we're able to ask questions using natural language and get nicely constructed answers back while avoiding hallucinations or retraining an LLM. And furthermore, we're able to see for ourselves the research that it's pulling from. Now let's go build it. Starting from Foundry, we'll begin by making a new project with a folder in it for this course. If you already have a project from previous learn.palantir.com courses, no need to make a new one. If you don't yet have a project, navigate to Files, click on New Project, give your project a name, and click Create. Now, in your project, you're going to click New Folder, and give the folder a name, such as Speedrun, your first end-to-end AIP workflow. And this is where we're going to be storing all of our work for this course. Our next step is to upload data. Download the data from learn.palantir.com under the Introduction tab of the Uploading Data step, and click on each hyperlink to download the file. Once you've downloaded the data, you'll navigate to your folder, go to New, Upload Files, choose from your computer, select all of the files that you downloaded, click Open, and pick that first option, which is to upload as a media set. And then click Next. For the latency, keep it as batch, and then hit Upload. And then click Done, and now we're going to rename this to give it a name that we can understand. Click Rename, and we'll rename this to Articles. Now let's click into this and see what it looks like. If you click on Articles, you can see a preview of all of the PDFs that we've uploaded. And you can peruse them through this view. Note also that it's collected some metadata about the PDF, such as the author and the title. Also note that a media set has a different icon than a data set does. Whenever you see this icon, it always refers to a media set. And now that we've set up our project, made a folder, and uploaded the data, we're ready to get started on transforming the data. When we transform the data, we're going to start with the articles and process it into two data sets, one that is chunks of text and one that is the entities that the text mentions. To do this, we're going to first start from our project and click on New, go to Pipeline Builder, call this one Document Processing Transform, and make sure the pipeline type is batch, and then we'll click Create Pipeline. Now, we're going to need to get the data in here, so click Add Foundry Data. And it took us right to the folder that we created for this course, which has our articles media set in it. So we'll click that and then Add Data. Here we are in our pipeline, and we have our media set. Starting from articles, you're going to click the transform icon. And note that there's only one operation we can do here because it's a media set, and that's to convert it to table rows. So we'll select that one and hit Apply. The next thing that we're going to do is extract the text from the PDF. We're going to search for PDF and hit PDF text extraction. Now note that there are two extract methods. There is raw text and OCR, or optical character recognition. If you're using a machine-readable PDF, which in this case we are, raw text will work just fine. However, if you're using a photo of a PDF or a photocopy or a scan of a PDF, you may need to use optical character recognition. So keep that in mind if you're using your own PDFs. Now we have to select the media reference. Note that in the table that we just created out of the media set, we have a media reference column. The media reference column is used to refer to media without actually copying over the media itself. This allows us to efficiently manage and display media in other applications. So for the media reference column, it only allows us to pick the column that is actually of a type media reference. So click that one. For the start page, you'll start at page 1, which is the default, and you don't need to specify an end page. Now rename the column to Content, and then click Apply. And now that the PDF text extraction has completed, we can see the results. So when we hover over Content, we can see indeed that it's extracted the text from the PDF, and it's an array of strings. The next thing that we're going to do is explode array with position, which will take the input array and create a new row for each element of the array, while maintaining the position, which is the page number. So we'll search for explode array with position. And for the array, we have one option, which is content. Keep this set to false and click Apply. And now we have a new column, which is a struct. Our struct has two fields, position and element. Position being the page number and element being the actual text. Now, there's not a lot that we can do with this struct column. So we're going to turn it into two columns, one that contains page number and one that contains the text. So we'll search for extract many struct fields. Click on that. For the struct column, we have one option, it's content. And for the locators, we have position, which we will name page number. And we'll add an item, and this one will be element, which will be the actual text, which we'll call content. And then click Apply. And now we have two new columns. We have the page number and the content, which is just the text. Now, if you haven't yet, be sure to name your transform. I called mine extract pages. Make sure all your changes are applied and go back to the graph. The next thing that we're going to do is extract chunks from the text. Chunking the text breaks it up into smaller, more manageable pieces, which enables it to be used more effectively by a large language model. So from extract pages, we'll click transform, call this one extract chunks. And for our first transform block, we'll search for chunk string. So for the expression, we're selecting the column that contains the text, which is called content. For the chunk size, the default is 256, but we're going to change ours to 512. For chunk overlap, we're going to keep that at 0. And for the separators, we're not going to change anything. Keep separator is set to true. And then click apply. And now content is once again an array. And so by chunking, we've split up our string into an array of strings. The next thing that we're going to do is another explode array with position, which again will create a new row for every element of the array while maintaining the position. In this case, instead of being page number, the position is the spot on the page. So we'll search for explode array with position. The array is content. Keep this set to false. Make sure the output column is called content. And then click apply. And now we can take a look at what we've got. And once again, we have a struct with two fields. We have position and element. And note that for each page number, we have many chunks of content. So the position in this case refers to a specific place on the page within the document. And now, once again, we're going to want to turn this into a string so we can work with it. So we're going to search for extract many struct fields. The struct is content. And for the locator, we have position, which we're going to call chunk number. And then we add an item, element, which we're going to call content, overriding that column. And then click apply. And now we have a chunk number, which is an integer, and the content. And you can see that the content chunks are now much shorter than the original pages. Now make sure all your changes are applied, make sure your transform is named, and go back to the graph. Next, we're going to do another transform. Call this one create chunk ID. And now we're going to search for the concatenate strings transform. For the separator, we're using an underscore. For the first element, we're going to select the media item RID. And for the second and third elements, we're going to want to use page number and chunk number, but they're integers, and we're only allowed to concatenate strings. So the next thing that we're going to do is instead of picking a column, we're going to pick expressions, choose cast, and we're going to be casting page number to a string. And we're going to add an item. Once again, it's going to be an expression, which is cast. And we're going to be casting chunk number to string. And now call this chunk ID. Now, the reason that we're doing this is because eventually we want chunks to be an object in the ontology. And in order for that to happen, we're going to have a primary key. This is going to be our primary key. And we know it's going to be unique because the media item RID is for the PDF, which we've concatenated with the page number, which we've concatenated with the chunk number. So we know it's going to be unique to the specific chunk. Then we'll click apply. And now we can see that we have this chunk ID string column. To verify that it's unique, we can click on View Stats and see that indeed there are 578 distinct values and 578 rows. Now make sure you've applied everything and go back to the graph. Next, we're going to use an LLM to summarize the articles and extract entities. So from chunk ID, we'll go to Use LLM. And note that we're not using generate. We're using use LLM. And now we have options. With use LLM, you can perform classification, summarization, translation, sentiment analysis, entity abstraction. But for our purposes, we're actually going to start with an empty prompt. So for the prompt, you'll copy the prompt that you're given on learn.palantir.com. And then for the input data, type a /, and the input data is content. For the model, we can keep it as GPT-4o, but note that if you click Show Configurations, there are other things you can configure, such as the model type, the temperature, max tokens, etc. Now for the output type, instead of a string, we're going to select that to be a struct. And for the first field, we're going to call this one summary, and it's going to be a string. Next, we want it to list out entities. And so we're going to call this one entities. And because we want multiple entities, we're going to make this an array. And it's going to be an array of strings. For the output column, we will call it response. In order to test this out, we're going to click on Input Table, click a couple of rows just to try this out, and hit Use Rows for Trial Run. Now we can click Run here to see the output of the model. And now we have the returned results. So in our struct, we have a summary. So this is the summary for the chunk. And there were no entities found for this example. Now, if we look at other examples, we can see it did return a summary, and the entity it returned is tuberculosis. Now, if we want to try this on a couple of other rows, we can select some more. Use rows for trial run, hit run. And now we've got some more interesting results. So here we have the summary, and then we have the extracted entities, which were both diseases and treatments. Now, at this point, if you're not happy with your results, you can go back to the instructions or the prompt and change them so you get better results. You can also test it out on a couple more subsets of the rows. Now, before we move on, let's talk about what's actually happening here. Normally, when you're using a large language model in, say, a chat engine, you send the LLM your prompt and get back a response. In this case, we're doing the same thing. However, there is extra work being done under the hood to make this useful on actual data. So we have the prompt here, which you'll be familiar with if you used, say, ChatGPT before. And then we have actual data augmenting the prompt, which is the content. Now, under the hood, Pipeline Builder is actually taking every row of content, passing it in with this prompt, and actually sending it to AIP to get a summary and the entities. If you were doing this, say, on your local machine, you might have to loop through data. Now we'll click Apply, and then go back to the graph. The next thing that we're going to do is create embeddings. Embeddings represent text as a point in high-dimensional space so that similar concepts end up near each other. Once we have an embedding property, this can be used to carry out semantic search. So to create our embeddings, we're going to start from the output of the Use LLM block, click Transform, and we'll call this transform embed chunks. And we're going to search for get struct field and take the response column from the LLM and set summary as the property to extract. And then click Apply. And now we've extracted summary from the response. The next thing that we're going to do is take this text and produce an embedding from it. So we'll search for embedding and select text to embeddings. For the text column, we're going to select summary and rename this embedding. And then we're going to click Apply. Now, finally, we're going to drop the responses column. Select response and click Apply. Our next step here is going to be to produce an output dataset. So we'll click back to graph, and then from embed chunks, you'll click on the node, go to add output, new dataset, and call this one chunks. And we're going to keep all of the columns in the dataset that we have now. Now, note that we've created this output dataset, but it hasn't actually been built yet because we haven't hit deploy. We'll do that at the end. Next, we're going to go get the entities that we generated in this step. So from this node, you're going to click on Use LLM, click on the transform, rename this node Get Entities. And now let's take a look at what we have to do. The response column in this step is still a struct field, meaning that we have two items. One is summary, which we just dealt with, and we also have the entities. So we're going to have to extract fields from the struct and explode the array to get all the elements. So we'll search for get struct field. The struct column, we have one option, it's response. For the locator, this time we're going to select Entity and click Apply. And now we have entities as an array of strings. The next thing that we're going to do is explode the array. So we'll search for explode array. Now, this time we don't need to retain the position. Note that this time we're just using a normal explode rather than an explode array with position. For the expression, we're going to use entities, keep this set to false, and rename the output to entity name. And click Apply. And now we have our results. So now we have a row for each entity. Make sure you've applied all your changes, and we're going to go back to the graph. Now, let's take a look at what we have here in the entity name. This is just a preview for now, but notice that we already have a lot of duplicates. Just in these 10 rows, we have tuberculosis 4 times. We'll need to do some deduplication. So from this last node, get entities, we're going to do another transform. First, we're going to select only the entities, apply that. And then the next thing that we're going to do is drop duplicates. The column that we're dropping duplicates based on is entity's name. And then we'll click Apply. And now you'll see that we've gotten rid of the duplicates. And now, for example, we only have tuberculosis once. Make sure your changes are applied. Make sure you've given your transform a name, such as deduplicate entities. Make sure you've applied and go back to the graph. Now, we've created an output for chunks, but we still need to create an output for entities. To do that, we're going to click on the entities node, go to Add Output, New Dataset, and call this one entities. And note that this one should only have one column. Once we're in the ontology, we're going to want a way to associate the entities with the chunks in order to perform search rounds in the ontology. To do that, we're going to start from the get entities transform node. And we know that we should start here because we have both the entity's name here and the chunk ID. So we'll be able to derive a join table from this data set. So from get entities, we'll make another transform. Let's call this one get join table. We'll select columns. The columns that we're selecting are just entity name and chunk ID. And then we'll click Apply. And make sure all of your changes are applied. We'll go back to the graph. And now we're going to make one more output data set. So click on Get Join Table, go to the gold Add Output, New Data Set, and we'll call this one Join Table. You'll have 2 columns, entity's name and chunk ID. Now let's take a step back and talk about why we actually need a join table here. A single chunk might mention multiple entities, and a single entity might be mentioned in multiple chunks. Therefore, we can't make a link on these future objects based on a simple primary key foreign key relation. This is why we need a join table so that we can create a many-to-many relation in the ontology. Now we're ready to save and deploy. So in the upper corner, you're going to hit save and deploy, and then deploy. If you get this warning, just click Import Resources. It will prompt you to import GPT-4o or whichever model you used, and the embeddings creation model. Click Add References, and then hit Deploy again. And now our deployment has succeeded and our data sets are built. This concludes our data transformation. In summary, we started all the way back there with a media set, extracted the pages, extracted the chunks, created the chunk ID column, used an LLM to summarize the chunks and extract the entities, created embeddings for the chunks, and then created the chunks dataset. And then in parallel, we extracted the entities, deduplicated them, and created an entities dataset. And over here, we created a join table so that we can create a many-to-many relation in the ontology. Now we'll move on to configuring the ontology. At this point, we've gotten to here. We've created a data set of chunks and a data set of entities. And now we're at this step where we'll create a chunk object and an entity object. Next, we're going to navigate to the Ontology Manager application and configure our object types. So from here, you can type Control-J and search for Ontology Manager. We'll click on that. Now, here we are in the Ontology Manager. To create an object, we're going to click New and then New Object Type. If you're able to do that, then no need to follow the next couple of steps. But if this button is not available to you, you might have to create your ontology changes on a branch. To do that, you'll go up to Main, Create Branch, create your branch theme, and then hit Create Branch. Now, regardless of if you had to create a branch, the steps from here on out will be the same. So you'll go to New, New Object Type. The name, make sure to prefix it with your first name, so as not to get confused if your colleagues are also working on this lesson. We'll call this one Chunk. The object name plural auto-populates. Then we'll select our data source. For the data source, we search for chunks, select it, and then go to Next. For the primary key, we will use the chunk ID column that we generated. And for the title, we'll use summary because it's not too long, but it's descriptive and human readable. And then we'll click Next. Keep the permissions as they are. Click Next. And now we're going to generate the action types associated with this object. So we'll select all of these. Enable only ourselves to carry them out. And then click Create. Now that we've created the object, we're going to have to modify some properties so they'll work for our applications. First, we're going to change embeddings. If we click on embeddings, you'll see that the base type is a float. However, in order to use this in semantic search, we need this to be a vector. So we'll select vector. And now we have to provide some additional information. Keep the similarity function as cosine. And for the embedding model, we're using the language modeling service model that's been pre-configured. So we'll select that one. And notice that when we select that, it automatically filled out the dimensions for us. For the embedding model, it automatically selected the right one for us, but make sure that the model selected here is the same one that you're using in Pipeline Builder to create the embeddings in the first place. Next, we have to change the media reference from a string to a media reference. When we select media reference, it's going to make us associate the property with an actual media set. And this is where the media set that we started all the way at the beginning with will come in play. So we click Add Media Source, and you're going to search for articles. And then hit Select. And now we can set it as a media reference property. Now that we've created our objects and our actions, it's time to save our work. So we'll hit Save, and then Save to Branch. And we get an error. It says, failed to save changes to ontology metadata prefill value type does not match base parameter type. The reason that this happened is because when we created the chunk object, we also created associated actions. However, we created those actions before we changed embedding from a float to a vector, and before we changed media reference from a string to a media reference property. Therefore, the actions were created to expect a float and a string, respectively, which were the original types of embedding and media reference. To fix this, we'll have to amend the actions that we created and get rid of those parameters. If you hover over this back arrow, you can see the objects and the actions that you've recently created. So first, we'll fix this one, create chunk. So if I click on that and go into the rules right away, I can see that media reference, the property, is not compatible with what it's mapped to, which is a string. So I'll get rid of this one. Now in the error, it explicitly mentioned the embedding property, so I'm going to get rid of that one too. Now for consistency, I'm also going to get rid of those in the form. All right, and now we fixed create chunk. Next, we're going to fix edit chunk. Same thing, go to rules, get rid of embedding, and get rid of media reference. Now go to the form and do the same. Now let's take a look at the delete chunk action. Note that this one doesn't explicitly refer to the embeddings or the media reference properties, so there's nothing that we need to change here. Now that we've changed those actions, we should be able to save our work. So we'll hit save again, save to branch, and it's successful. Next up, we're going to create the entity object type. So go to New, Object Type. Remember to prefix it with your name. And for the data source, we'll go select Entities. Select that, hit Next. For the primary key, well, we only have one column in this data set. So the primary key and the title key are the same, and they are entity name. And then we'll hit Next. We'll leave this as it is. Go to Next. And now we have the option to generate action types. Note that we only have the option to create actions and delete actions. The reason why we don't have the option to create a modify action is because there's only one property on this object, and it's a primary key. We can never modify the primary key, which is why we're not allowed to generate this action. Select yourself as the user who can carry it out, and then hit Create. And now we're going to save again. If you get this error, just refresh the page and try again. Next, we're going to configure the many-to-many relation between entity and chunk. So we'll go to New Link Type, and on this side, we'll choose chunk. And on the other side, we will choose entity. Now make sure the cardinality is many to many. Now when we click many to many, it's going to make us select the dataset for the join table. Search for join table. And now we have to select the columns that contain the primary keys. So for chunk, that's going to be chunk ID. And for entity, that is going to be entity name. And now the link is properly configured, and we're going to hit save. The last thing that we have to do is merge our changes into the master branch. Now, if you didn't make a branch to begin with, you don't have to follow this step. But if you did, what we're going to do is at the black bar at the top, we'll click Open Proposal Details. If you see this ribbon, click Update. And now you're going to have to ask for review. Now, in my case, I'm going to be approving my own proposal, but you might have to have a colleague approve yours. So I'll ask for review from myself. Approve all edits. And then we click Merge. And now we've merged our branch. So if we go back home to Ontology Manager, we're going to be able to see our objects. Now that we've created our ontology objects, we're going to create a knowledge graph using Vertex. So starting from your project, you're going to make a new Vertex graph. So we'll hit New, search for Vertex graph, and now we have our empty Vertex graph. And let's give this a name. We'll call it knowledge graph. Now let's add some objects to the graph. So we'll hit Add Objects. You can type your name in to find your objects. Now, if your object type is grayed out, go ahead and check in the Ontology Manager and make sure it's not still indexing. If it's still indexing, it will have a little loading sign here. Additionally, under the Data Sources tab, all of this should be green check marks. If it's not yet, if you're seeing any loading signs, just give it a few minutes and then come back to it. So select Chunk, and then hold down the Shift key while clicking to get a selection of chunk objects. You can get somewhere between 10, 20. So we'll add the selected ones, and then click anywhere on the graph to add the objects. And note that they're all selected already, but if I click outside somewhere here, that will unselect them. And to reselect them all, I can type Control A, and it will select everything. The first thing that we're going to do here is search around. So go to search around and search around to entity. And now it's showing us all of the entities that are linked to the specific chunks that are on our graph right now. The next thing that we're going to do is alter the layout because it's very clustered together right now. To do that, we'll hit Control A, go to Layout, and hit Radial. And now we've changed our graph to a radial layout. In this case, though, we've created this graph for a specific set of 20 or so chunks. However, what if I wanted to see this graph for a different set of chunks? What if my colleague wants to use it to look at a different set of chunks? To do that, we'll create a Vertex template. You'll do that by going to the Save button, hitting the dropdown, Save as a template. So since this is a template, it's going to expect parameters, and we have to tell it which object type it can expect. So we'll click Add Parameter. We'll hit Chunk. No non-object parameters needed here. And then click Continue. For the search arounds, we're going to be searching around to Entity. Click Continue. Nothing else to configure here, so we'll hit Continue. For the name, make sure you call it something like Knowledge Graph Template. Just give it a descriptive name. And for the layout, make sure you have radial selected. And then Continue. Now, there are a couple of other settings you can change here, but we don't need to do any of them. View Summary, and then we'll save the template. And then we'll hit Save. And now we've created our template. So now we can repeat this exploration, but maybe starting with a different set of objects. We're going to leave this alone for now, but we'll come back to it towards the end. Now that we've completed our knowledge graph, we're going to move on to setting up ontology-aided generation using AIP logic. Ontology-aided generation means that we're giving an LLM information that it's not trained on, but is able to query. By doing that, we're able to get better answers that are more relevant to our work and avoid hallucinations by the LLM. So starting from your project, you're going to make a new logic function. So go to New, type in logic, select AIP logic. Now give it a name, Ontology Augmented Generation, and hit Save. Now a function needs inputs. So at the top here, we're going to say add a function input. You can think of this like a prompt. This will be part of our prompt into the LLM. So this input will be called user question, and it's going to be a string. The next thing that we're going to do is create a variable. So hover over the toolbar, click on it, and we're going to call this one all chunks. Now the type is going to be an object set. The object type is going to be chunks. So select the chunks object. Now we have a variable that is an object set. The next thing that we're going to do is add a semantic search block. So hover over the magnifying glass, click on it. And in order to perform semantic search, we have to give it an object set to search over. So we'll select our all chunks variable. For the property to search, we have one option here, and that's the embedding. This is the embedding property that we created all the way back in Pipeline Builder and specifically configured to be a vector in the Ontology Manager. So click on Embedding. The number of returned objects, this is the number of objects it returns when it performs the search. So this should be a reasonably small number so that you're not getting too many objects returned. So let's set this to 10. But this could also say be a user input. Now for the query, which is going to use to actually perform semantic search, we'll click into the box, go to Parameters, and select a user question. And now we've configured our semantic search block. The next block is going to be a use LLM function block. So we'll hover over this second one in the toolbar, click on it, and now let's fill this out. There are two prompts here. You have the system prompt and the task prompt. You can think of the system prompt like a job description, and you can think of a task prompt like the specific thing that you're given to do. So for the system prompt, paste the system prompt from learn.palantir.com. And for the task prompt, paste the task prompt from learn.palantir.com. Now, note that the task prompt is not actually using the user question. So we'll delete this little block here, type a /, and select user question. Similarly, where we refer to semantic search here, it's not actually referring to the semantic search output in the function. So we'll delete that. We'll type a /, select searched all chunks, which is the name of my semantic search block. Yours might be different. And for the property, we'll use content and add the property. Now, note that we're using the embedding property to perform semantic search on the object set. But in order to compose a response, we want the LLM to return something human readable. Embeddings aren't human readable. And so to write the response, we have the LLM use the content from the returned objects from semantic search. And the output type is a string, which is correct. Now, a function also has an output. Double check that the output of the function is indeed use LLM. Now it's time to test things out. On the right side here, we have the preview run view. If you can't see this, it might be collapsed. To pull up the preview run, click on the triangle here, and you'll be able to test out your function. So for the user question, you'll ask some question that's relevant to the information at hand. So for example, what is the recommended treatment for tuberculosis? So we'll hit preview run. And note that it also opened up the debugger, which tells us what the function is doing as it's doing it. So this is successfully run and returned an output that makes sense. You're welcome to try out other questions and adjust the prompt. So we can try, for example, how common is tuberculosis these days? Hit run. And now we have another answer that makes sense. Now that we've verified that our function works and is returning sensible output, we'll publish it. So we'll hit save and then publish. So we have the function details here. We have the name and the API name, which is how this function is referenced in code. Now, this can be important. If you're doing this course at the same time as some colleagues, you might have functions that have identical API names. That might be a problem and you won't be able to save. In order to avoid that, just put your name at the end, and this will save you from any sort of collisions. And then we'll hit publish. So in summary, you now have an AIP-powered agent that can answer questions using your organization's ontology. The next step is to build a user interface for your team to access it. In this section, we have since created our AIP logic function, we've created our knowledge graph, and now we're going to make a user-friendly application so we can surface all the work that we've done. So starting from your folder, you're going to click New, and this time you're going to type in Workshop Module. We're going to give it a name, call this Ontology Augmented Generation App. Now, the first thing that we're going to do is change the layout of the application to better suit our use case. To do that, we'll navigate to the layout pane, which is here. Make sure you're on the page layer. Now, in the configuration for the section all the way on the right, set the padding to regular and set the layout direction to rows. Now, we're going to need more space to build our app, so we'll add one more section. So clicking on the top box here, on the upper toolbar, we'll click Above to add a section above. In your new section, hit Add Widget, and we're going to search for the Text Input widget. Click on that. The role of the Text Input widget is to collect user input in the form of text. Let's first give it a label. And note that it produces an output, which is where the user input is stored. So if I type, say, hello, you can see that the current value of text input 1 string value is now hello. Let's rename this to user question. The next thing that we're going to do is click into this next section, click Set Layout, and we're going to change the layout to columns. That means that the sections within the section are going to be sharing space horizontally. Now, clicking on the outer section here, we're going to get rid of the section header, and we're going to set the row height of this section to flex. Now, in our section on the left, we're going to add a widget, and it's going to be an object list widget. Now we have to get data to show up here. To do that, we'll go on the right-hand side to the configuration. Under Object Set, we're going to click Create New Object Set Variable, and we're going to call this one Relevant Chunks. The starting object set is going to be chunks. The next thing that we're going to do is click Filter on a property, and we'll search for the embedding property. And note that just by selecting the embedding property as the property that I'm filtering on, Workshop sets up a semantic search for me. So what this will do is it will take the chunk object and then perform a semantic search using that user query. For the embedding, we'll keep it at k-nearest neighbors. For the query, that's where user question comes in. And notice when I hover over the variable, the widget that produces it lights up. So we'll select that one. For the k value, we're going to select that to 10. And now that we've provided data to the object list, it's populating in the widget. The next thing that we're going to do is add in our Vertex graph template and display it here. To do that, we'll click Add Widget, type in Vertex graph widget. Select the resource. You'll look for the knowledge graph template that you saved earlier. And this template requires input. So you're going to have to feed it an object set variable. So you'll select relevant chunks from the dropdown. And now that we provided a template input, we're able to dynamically render the Vertex graph based on the inputs here. Now we're going to fill out this last section here. We'll click on the section, get rid of the section header. We'll set the row height to auto, and then click Add Widget. We're specifically going to add a Markdown widget. Select Markdown. A Markdown widget is purely for displaying text, and that text can be static or a variable. In this case, select Variable. Select the dropdown and click New String Variable. And notice that you have choices for how you actually define your string variable. In this case, you want it to be a function, so we'll name this AIP Response. And for the function, click the logic function that you published earlier, which is Ontology Augmented Generation. You'll see that it requires user inputs. That is the input that we configured in the function at the top. You're seeing it here in the variable configuration. So for the user question, we'll pick our user question variable. Now, it's returning a null because there's no user question here. So in order to make sure our app works as expected, let's type a question, such as, what is the recommended treatment for tuberculosis? And you'll see that the resulting chunks changes based off of the question, and also the resulting vertex graph changes because the vertex graph gets its input from the resulting objects from the question. And down here, we have the Markdown widget displaying the LLM-generated response, which uses the logic function that we made in our earlier step. Now make sure to click Save and Publish so you don't lose your work. And now you've completed your application and it's ready to be surfaced to users. So to summarize what we did to get here, we started by uploading data to a media set. We processed the data using Pipeline Builder to produce embeddings, extract entities, and get a join table. From there, we created 2 objects, several actions, and 1 link. Then, we made and templatized a vertex graph. Next, we built a function using AIP logic to perform a semantic search on our chunks and use an LLM to produce a response that makes sense. Finally, we put it all together into this application. This concludes our workflow. You've created an app that allows you to ask questions about tuberculosis, with your AIP agent delivering accurate answers and showing key points of the knowledge graph for further review. Thanks for watching, and be sure to let us know in the comments which tutorials you want to see next.